Narcís Parés. He's here with many people of his group from the Pompeu Fabra University. He's a good friend because he did his master long ago.
91 to 93.
Yeah, and then he moved to Pompeu Fabra, working in other lines, not computer vision, but computer vision is complementary with the topic they will explain us today. And actually the idea of this seminar is not only to know what they are doing, but also to try to find collaborations, because there are some probably possibilities of integrating some computer vision tasks in the project or the projects they have. So feel free after seeing the seminar to interact with them, to propose ideas, or just to say in the future I would like to participate in this possible joint project. Thank you for coming.
All right, I will just introduce a little bit the context and our group, and then Laura, who is a postdoc with me, will do the actual presentation of the topic. Thank you for being here. Our group is the Cognitive Media Technologies group, and I lead the branch of the group that is interested in full body interaction. We have a lab in which we do research on full body interaction, not only from a practical standpoint, but also from a theoretical standpoint, trying to understand what its potential can be, how it is informed by general theories such as embodied cognition, psychopedagogy, physiology, and how all that allows us to understand these technologies not only as a technology that can be used and applied, but also as a way of mediating experiences to users in a very different way. How that can lead to helping learning processes, or how it can lead to helping in disabilities, or how it can lead to use playfulness and play in general as a developmental process in human beings, and how that can foster different aspects of our development. So that's why we also tend to focus very much on children. The idea today is that we have been analyzing a part of augmented reality type of technologies. We have been worried about how augmented reality can be incorporated in public space, and how it can be enhanced, or how it can be integrated with the idea of moving in space of the users, how you are moving in physical and virtual space at the same time, what this symbiosis means, how you can be generating meaning in the process of interacting with the applications, how that experience can be mediated, and obviously the main part of augmented reality that we have available nowadays is based on mobile technologies. But we have started to get interested in these other branch of technologies, which are also increasing nowadays, which is based on projective augmentation of the physical space. Technology is advancing a lot, and we have done some theoretical analysis on how we see the potential of this type of technologies added to how the system could be understanding the geometry and the contextual information of the environment. And we have come to call this the world as support paradigm, interaction paradigm, in contrast to the window on the world interaction paradigm, which is the one based on the typical mobile or tablet applications. And Laura, she is doing her research in the area of how this can be applied to non-formal learning, and also in creative aspects of the development of children. And we wanted to present you today both the theoretical framework that we have been defining of this paradigm, and some specific study that she has done comparing the two paradigms, to try to motivate you to help us in developing the underlying technologies that we need now, because we are now working with very low-tech prototypes. And although there's already quite a bit of technology developed nowadays out there, it's being used in a very low profile way. The applications that we have seen are very like the immediate idea that would come to your head in how to use that, but it's not like really digging into all that, and that's what we are interested in doing in the next future years, especially because we have certain areas in which we are very confident that this can have very important application, not only in what Laura has been doing, but also in applying it to museums, but also to outdoors spaces such as historical sites and cultural heritage in general, and in different aspects of learning processes for children and helping them there. So I leave you with Laura, and she will explain you more about this. Thank you.
Hi, welcome everybody. I will set up the presentation right now. Okay. Well, as Narcisse presented me, I'm Laura Marinverni. I'm here to present a little bit the research around what we call the World as Support paradigm, and consequently the World as Support project. Basically, the idea of this paradigm is to provide an augmented reality experience that it's directly visible in the physical environment instead of being mediating via screen, and that is actionable by the people that are passing around. Let's see, for instance, in this image, this could be an example of having one child projecting something on the wall, the other interacting with this image and creating something, and for instance, other passerby being able to see what is happening and even intervene or comment upon it or give their contribution. Our idea is that this system can have different potential. On the one hand, most of augmented reality experience right now are based on the mediation of the screen. You see a layer of digital content on the stream of the camera. Nonetheless, this ends up being an experience that somehow it's quite individual because you have your own device, and also your interaction, it's not really with the physical space, but basically it's mediated and it's limited in the frame of the device and do not allow to really explore or understand what is happening in your environment. So starting from this premise and this limitation that we noticed, for instance, by working with children, that if they give you an augmented reality experience, they tend to focus mainly on the screen and just experience the external world as some kind of background that can be changed, but their attention is all on the screen, and also it's more an individual experience where maybe they can comment with somebody else that they are really friends, but they are not really sharing with somebody that they don't really want to involve specifically. So basically, based on these two aspects, our goals is to somehow develop a new interaction paradigm called the World as Support that can offer different features, such as being able to dynamically recognize the world, dynamically recognize people physical interaction in the world, project digital content according to the feature of the physical world, and being able of interacting with this digital content by physically exploring it. Starting from this part that is this like back end of development, the idea is to explore and develop a set of applications to exploit its potential in different fields. It could be education, creativity, cultural heritage, or other possibilities that can be explored. There are a bunch of previous research in this area that, on the one hand, a strand of research right now it's focusing on try to bring interaction outside the screen, try to put interaction and technology in the physical world and use the physical world to interact with this technology instead of having an experience that is completely mediated and enclosed in somehow this framing experience of the screen. Example of that can be found in this Microsoft project related to expanding the video game experience behind the screen of the game, but including the whole room, and for instance having the room reacting to, I don't know, like a shotgun or whatever, in order to somehow involve more senses, involve peripheral vision, creating a bigger sense of immersion and of digging into the gaming experience. Another example is the Sixth Sense project developed at MIT, where basically they use a projector and a computer vision system to allow you to project in the world and interact with your hand as if the world is some kind of a canvas where you can interact with it. Similarly, other strand of research has focused on start to explore the use of small portable projector, like Pico projector, to having this experience of augmenting the physical world and being capable of interacting with them. The first project, it's a project developed by Molinos et al., and basically they integrate a Kinect with a Pico projector. The Kinect allows to physically recognize the environment and subsequently augment it by projecting content that is intelligently adapted to it. Like, for instance, if it see a surface, it projects something that can have some relation with a surface. Similar, the second project and this one up here are projects developed by Wheels for Disney, and it's based on the idea of using a Pico projector to augment gaming experience for children by making visible this character through the use of infrared marker. These other two projects, this is called Shadow Puppet and this is Otaru, also are based on using Pico projector and then recognize the shadow of the other people who is interacting with this digital projector. And the last, it's based on using Pico projector and QR code to augment a cultural heritage site in Great Britain. This project offers some kind of flavor of possibility and of possible idea that can be developed, but mainly all of them have been focused mainly on trying to explore the technical potential of the system and try to improve the technical potential. And they are not really exploring a novel possible use. I don't know, for instance, this one, it's basically using a Google map and navigating the Google map through the system, but I don't know up to which point really it's more useful to have all this kind of system to just navigate in a Google map when maybe you can just do it with a normal digital representation on the phone. So a little bit the idea of our project is to really understand what are the affordance of the system and in which context this system can really make sense and give an added value with respect to other configuration. Also, from another perspective, there are interesting studies related with sensing technology and the use of computer vision to recognize the space. I think that in this context, the first one, it's based on Kinect and allow to use Kinect to dynamically recognize the space when moving the Kinect around. And the second, it's the Google project Tango that now also Lenovo is implementing in a new model of smartphone that basically use RGB camera and a fisheye camera to recognize the space, like for instance recognizing different surfaces or movement in the space, taking the distance and measurement. And right now, like the off-the-shelf product of this Lenovo technology, it's this mobile phone by Lenovo that basically it's proposed as a platform, but there are just few application of it that are basically like a virtual pet and a system like to see your furniture, augmented furniture in the space and look at how it will look, but it's like a platform open for development. Starting from this previous research, we define the idea of the world of support as an augmented mixed reality paradigm based on mobile technology and the handheld projector that has the goal to augment the world in a meaningful way, in a way that allows to this medium to really make sense and allow users to interact with digital technology in a shared space and by also facilitating instance for socialization. Its feature is that on the one hand, as I say before, it allows to avoid the mediating role of the screen and it enables a more direct and less constrained interaction with the space. Also, it all these kind of augmented mixed reality technology are based on the appeal of making visible something that is not there. But by using more projective technology, it can allow to really make this augmentation somehow more present and more visible in the environment, and also transform every possible place as a place for interacting, for physical interacting with technology, therefore exploiting the richness of using your whole body or to interact with digital technology and not just the finger and eyes relationship. Also, it can support applications that are based on socializing or sharing content instead of having a personal use of them. Starting from this affordance that we see several potential that are related to, for instance, design of interactive system for social and public situation, for the exploration of relevant sites, as it could be public spaces, cultural heritage sites, museum, to foster engagement with specific physical environment that may be of interest, to promote collaboration, and also to offer a more holistic understanding of your surrounding that is not just framed by a mediating screen, but it allows you to also with your body and your explore the whole surrounding. Possible case of use can be, for instance, transform every place in an interactive playground, as it could be both a domestic environment as well as a urban square, a plaza, or a city. Also, transform every place in an interactive museum, as it could be both cultural heritage sites or more workplace that need some kind of promoting themselves for visitor. Also, it can have some potential to support collaborative working process or for data visualization. Other benefit maybe to promote navigation or some potential application in performative and visual art. Some possible example that in this case, for instance, in the cultural heritage sites could be related with the way of using this kind of technology to support user taking different perspective. I took here as an example the statue of Bolivar that is in the city of Medellin, and this statue is quite interesting from a cultural perspective because basically Bolivar was the person that freed Colombia from colonization, but all the statue has been built from European sculptor and architects. All the material come from Europe, and for instance, if you are provided with this kind of device, for instance, by locate yourself in different position around the statue, you can see the different way of telling this story and all the layers that this story contain by moving around in the space. Another possibility, for instance, could be for visiting cultural heritage sites by allowing user to inhabit different perspective of different inhabitants. Let's say being somebody rich in a certain era, or being somebody poor, or being a woman. What does it mean? How do you live the space if you were a woman in a certain specific historical era? Also, okay, here another possibility are related with more play and playful engagement with the city. And this video, well, it's a little bit embarrassing because it's myself being an idiot in the video, but I will show it anyway. Okay, so in relation with this latter project that is more related with exploring more the creative and play and ludic aspect, we started an initial research with a school involving children in the design of their own character to make this character inhabit the space of the school and build narrative of their character within the school. In this project, we compared two configurations, one based on the aforementioned order support that basically was allowing children to project their character in the space, and the other based on traditional augmented reality Windows in the World configuration that was having their character displayed on a tablet device. Basically, children were invited to think about a place of the school that could be very interesting for them, imagine a character that can live in this place, draw this character, we then upload it in the application, and then they can go in group to explore how the character interact with the space, what they will do there, and what improvising their own narrative. We focus our evaluation in looking at how children use and understand the space, and on looking at how this device somehow shaped their social interaction and their way of dealing with each other and constructing each other narratives. Starting from this analysis, what was interesting to notice is that there was both in the use of the space as well as in their social interaction some important difference between the two paradigms. On the one hand, here we can see that for instance, the children that employ the order support, they employ this projective technology, tend to be much more aware of the space, using the space, for instance, as a context to build their story, like, okay, I have a spaghetti monster that is in the kitchen because he's going to eat all the nasty food that the school is giving us. or using the character for having some kind of sensory motor exploration of the space, making the character, I don't know, jump on a table, or exploring how it look if you try different texture for the projector, and also using the character as and the feature of the space as a prompt for narrative improvisation. For instance, okay, now the teacher is going to take the elevator and my zombie is going to attack the teacher and eat the teacher. These aspects were a little bit more reduced in the children that use the traditional augmented reality configuration, that is the red one, and many children in this case basically show behavior related to disregarding the space, like they were telling their story about their character, but it was not really site-specific or making a use of the surrounding that could be related with the character. Basically, the character could stand in whatever place and it will work anyway. Also, in relation with social interaction, we look specifically at whether children pay attention to each other while they were exploring the space with their character and telling their story, and whether they intervene by enriching the story of the other, for instance, by making comment or by giving direction in a sort of movie director mood, or by improving their story, or by directly acting in their story. What was interesting that here it's even more evident that by using the word of support, children tend to, on the one hand, be much more focused on what the other were doing. This was very important because in the case when children saw that their peers were not interested in their story, basically their story was really reduced and they lose a lot of their motivation in continuing exploring and telling. When they saw that the other were looking at them, were interested, were engaged with them, they were prompted to enrich their narrative and explore more deeply different possible configuration. Also, what was interesting is that in the worst condition with respect to the windows in the world, children intervene much more by giving comment, by giving suggestion, and especially by acting together with the character. For instance, okay, I'm projecting my zombie and I'm saying that it's going to do something, and another child go in front and try to shoot and kill the zombie in order to somehow give a narrative turns. So starting from these results that basically are summarized here, like our idea is to start developing a system that really afford and enable all this potential of, for instance, being an actor or having the content that adapt in an intelligent way to the environment, recognizing how other people can interact with your projector, and then enabling interaction. Because in the study we use a very unsophisticated prototype, let's say. It was basically a basic application that just allow you to project and while we rely on children imagination and fantasy to make all the rest of things working, but actually was nothing work. And our idea is that we already have some kind of base ground to explore more deeply this possibility that showed to be very interesting and very engaging for instance, in the context of having children creating and imagining other worlds that can inhabit our physical worlds. And well, basically that's, thank you.
So, are there any questions, comments? Have you seen systems that we might have not seen? interested in helping us out?
How do you do the computer vision part at this point?
At this point, we don't.
I am the computer vision.
Yeah, the thing is that, as Joseph said, I did my master's here in